This is section 3.1, page 143, numbers 27 through 30, and we're going to consider a company that selects employees for random drug testing. The company uses a computer to randomly select employee numbers that range from 1 to 6,296. So we're trying to find the probability of selecting a number less than 1,000. So to find the probability of something, I think they use probability E. It is just the F, which is the frequency of the thing that you want, over N, which is the total outcome. So our total here is always going to be, the denominator is always going to be the 6296. So to find a probability of selecting a number less than 1,000, well, how many numbers are less than 1,000 from 1 to 6296? So it's just going to be 999, and we're going to divide that by 6,296. So you put that in your calculator, and you'll end up with 0.1589 da 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 da. So we're going to round that off 3 decimal places. And so it'll be about 0.159. Just pay attention to what decimal places they want. Find the probability of selecting a number greater than 1,000. So the number is greater than 1,000 is just going to be the 6296 minus the 1,000 that are less than that. That's like the complement over the 6296. And so that'll give us 5,296 over 6,296. Put that in your calculator, divide that out, and you'll end up with 0.8411 something something something. So we're going to round that off. If you go 3 decimal places, rounded correctly, this one does nothing to the third digit, which is the one 841. We are asked to find the probability of selecting a number divisible by 1,000. So what numbers are divisible by 1,000? Well, 1,000 is divisible by 1,000, 2,000 is divisible by 1,000, 3,000 is divisible by 1,000, 4,000, 5,000, and 6,000. So how many numbers is that? Because 7,000 is not in there. So that's 1, 2, 3, 4, 5, 6. So that means there's only 6 out of that 6,296, which are divisible by 1,000. So when you divide that out in your calculator, if we take a look at this, I divided 6 divided by 6296. It gave me 9.5298 something 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 e to the negative 4. Well, that means 10 to the negative 4. So you're multiplying this by 10 to the negative 4. And what that means is you're going to move your decimal to the left 4 places. So let's take a look at that. We're going to take this 9.52968 something something something, and it's really being multiplied by 10 to the negative 4. Scientific notation here is we're going to move that decimal 4 places to the left. So we're going to go 1, 2, 3, 4, and we're going to move zeros in here. So we're going to say that this is about 0.000, let's say 95, we'll round that off, and give us a 3. And it depends on how many decimal places they want, but that's a good little rounded off there to show more accuracy. For number 30, find the probability of selecting a number that is not divisible by 1,000. Well, that's just going to be 1 minus the probability divisible by 1,000, or 6296, take away the 6 that are divisible by 1,000, divided by the 6296. So it's going to be a pretty high probability. So that's just 6,290 divided by 6,296. So when you divide that out in your calculator, you end up with 0.9990 something something something. So it's about 0.999, because this is about 0.0001 there. And so that's just calculating some probabilities, the frequency over the n. On page 143 of section 3.1, numbers 31 through 34, we have a probability experiment. Probability experiment consists of rolling a 6-sided die and spinning the spinner shown. We've got yellow, red, blue, and green with the spinner. And so a 6-sided die, you're either going to get a 1 or a 2, a 3, a 4, a 5, or a 6. You're going to do this and this. So these are independent of each other. Getting a 5 won't affect whether or not you're going to get blue. So the and means that we're going to be multiplying here. So for the first one, we're going to find the probability of rolling a 5. So the rolling a 5, well, there's only one 5, and there's 6 sides, so that's 1 6 times the probability of the spinner landing on blue. Well, there's 1 blue out of 4, and in the book you can see that all the sides are the same probability of happening of each color. So it's just 1 6 times 1/5, which is just 1 out of 30. So the probability of each thing is multiplied together, and these are independent And so you can just multiply their probabilities together. Let's take a look at event B. Here we're trying to find the probability of rolling an odd number and their spinner landing on green. So the odd number probability, well, which ones are odd? Well, 1, 3, and 5 are odd. So the probability of getting an odd number is going to be 3 out of how many total numbers are there, and that's 6. I'm going to multiply that by the probability of landing on green, which again is 1/4. And so that'll just give us 3 times 1 is 3, and 6 times 4 is 24. But we're going to reduce that by 3, and so that'll give us 1 out of 8. So the answer there is just going to be 1/8. For part C, we want to find the probability of rolling a number less than 6. Which numbers are less than 6? 1, 2, 3, 4, and 5. So the probability of that occurring is 5 out of 6 times, and then the probability of the spinner landing on yellow, well, there's 1 yellow out of 4 different colors and are equally likely each. So we're going to multiply 5 6 times 1/4, and that'll give us 5 out of 24. And we can't reduce that one. Now you can change these to decimals depending on what the computer wants. Well, let's take a look at the last one here. Event D is not rolling a number less than 6. So not rolling a number less than 6 means that it's got to be greater than or equal to 6. There's only one of those. Not rolling a number less than 6 is 1/6. And then the spinner landing on yellow is 1 out of 4. So that's going to give us 1 out of 24. You can use the tree diagram like I asked you to do in the textbook, but really you're just doing the and, so you can multiply. These are independent, so you can just multiply them together.